Welcome to a new episode of Science in Context. I'm Sabine, and this week Dr. Sam Horsfield joins me to speak about surveillance and diagnostic methods. Sam, you focused on Streptococcus specifically. Why is this so important?
Hi Sabine, thanks for having me on Science in Context. So our work builds upon some of the great stuff that was done during the COVID-19 pandemic using DNA sequencing for surveillance of novel variants of COVID. Our work focuses on Streptococcus pneumoniae, or pneumo for short. This is a bacterial pathogen that causes severe lung infections. So like with COVID, there are many variants of pneumo, and we have vaccines that cover a breadth of different variants. But because there are so many different variants and not all of them are covered, we need to have good surveillance systems to make sure that there aren't novel variants emerging, and we can do that using DNA sequencing.
And what makes your method stand out?
So our method uses Oxford nanopore DNA sequencers, which are machines that read off DNA like a sentence very quickly. Doing this, we can read off a DNA sentence, compare it to a DNA database, and get a good match as to what we think is in our sample, so we can identify a variant of pneumo. And the issue with this approach is that our DNA database is fixed. And so if we have one of our sequences in our DNA database is I like going on holiday, if we were to sequence something along the lines of on holiday I like going, so a different word order, if we try to match those two together, we wouldn't get a good match. Our method, called GNASTy, addresses this issue. So we represent the DNA database as a hairball-like structure, and this means we don't have to match based on word order, and we would get a match between those two sentences, for example.
That's amazing. And what is the real-life application of this method?
So we see it as being used in routine surveillance of Streptococcus pneumoniae. It allows us to identify novel variants that we haven't seen before, and we can then inform vaccine design and deployment to combat threats as they arise.
Amazing. Thank you so much for your time today.
Thank you, Sabine.